Every day, we eat something, put a cream on our skin, and cook with a pan like this, and almost none of us can read the label and know if it's safe. That's a public health problem hiding in plain sight. The information exists in food databases, cosmetic registries, and government records, but nobody has time to cross-reference it all standing in a store. So we built an agent that does it in seconds. We call it the Clean Label Agent. This isn't a simple lookup. To answer, "Is this safe?" the system has to identify what the product even is, pick the right database, pull every ingredient, check each one against chemical hazard data, judge its own confidence, and refuse to make any claim it can't prove. That chain of reasoning across multiple tools is exactly what an AI agent is for. Let's see it. I'll scan a classic Teflon pan. Because this is a high-risk product containing persistent toxins, the agent immediately pauses for human oversight. This 5-diff modal shows the raw database facts on the left, side by side with the agent's drafted summary on the right. Once I review and click Approve, it renders the final card. Unsafe because of PFOA, a carcinogen. It explains why, flags the chemicals of concern, cites its sources, and suggests a clean, ceramic-coated alternative you can buy with a single click. Here's what makes this agent different. Early in development, we scanned a sunscreen, and the agent called it fatal if swallowed, flagging harmless ingredients like citric acid as dangerous. The problem was actually twofold. First, the agent didn't recognize this as a skincare product, so it searched the wrong database entirely. Second, even once it found the ingredients, it applied raw industrial chemical hazard data directly to a finished consumer product, calling a safe ingredient like citric acid fatal if swallowed. So we rebuilt the identification step to determine what the product is and which category it belongs to before anything else. And we engineered a hallucination guard, so every hazard claim must trace back to real database data. It literally cannot invent a claim. That's why it now correctly reads a safe sunscreen as safe. Under the hood, this is powered by a multi-step agent graph built with the Google Agent Development Kit. Here, you can watch a scan for Vanicream route through our graph in real time. It normalizes the query, dynamically classifies the product as skincare to load the specialist skin skill, queries open beauty facts via MCP, and runs toxicology audits. Transitioning to our system architecture. The graph ensures every check is passed, delegating tasks to sub-agents and verifying claims before display. Every single node execution is traced in real time with open telemetry. And we didn't just hope it works. We built an LLM as judge evaluation across 12 real products, 3 per category, from Quaker Oats to Clorox bleach. All 12 verdicts were classified correctly across every evaluation case, with the judge scoring the explanations at 7 to 10 out of 10 under neutralized order bias. We built the Clean Label agent entirely by Vibe Coding in Gemini Anti-Gravity. As you can see, we worked spec first, writing prompts to direct the agent directly inside the chat. For example, we directed Anti-Gravity to fix the safer alternative logic when we caught it recommending bottled water for unsafe frozen pizza, and it immediately rewrote the classifier. Anti-Gravity did the heavy lifting, writing the Python code, automatically running our test commands in the background, and returning the logs directly in the conversation. We directed the architecture and never hit a single merge conflict. An agent that cites every source, refuses to guess, and knows a warning label from real danger. That's an agent that protects public health and educates you along the way. Thanks for watching.